Okay, good afternoon, everyone. Today we're going to take a look at how to do a CAD layout for a corner. Our example here is West Edge. We have these articulated type walls that have a lot of different degrees on the floor plans. And the mullion pairs that were available to be used in these conditions, some of them matched the floor plans exactly, and some of them were off by a few degrees. So in some cases, we had one mullion pair that was used for 3 different degree angles. And in order to do our setup process and our checking process, we need to be able to determine what our part cut lengths are, what our indexes are for where the glass goes, how far over our stops are going to be, etc. So we had a lot of layouts that we wound up needing to do. I'll quickly show just an example. This is one of the degrees that we did. It's a 134.6 degrees. It's built off of a 135 degree mullion pair. The mullion pairs in this case are parallel to each other, but the floor plan is specific to the 134.6. So what that does is it makes the miter degree slightly different than if you had built it to the 135. We needed to be able to take these and place them in any of the different locations around the floor plan so we could tell what the size of the unit's going to be. This is also in conjunction with a Kaizen that I've got percolating on being able to generate segmented walls and what the different stages of the process are. So at this point on West Edge, we're experimenting with creating the layouts and then possibly even placing those onto the floor plans so that we can get all of the sizes done. So I created a video on how I took an existing layout and converted that to the various degrees. So we'll start by watching that. And then if we need to go into further detail or clarify some additional items, then we can do a live demo after that based on taking this drawing, for example, and tinkering with it in order to further explain these points. So the video itself, if you go to the portal and under engineering and training, and under training content, we have takeoff training. And then we broke this up into categories. So we have the program training up above, the checking training down below. So the lesson that Mario created for checking the compound miters with CAD is here. And then this is the one that I put on there for today's session, is the corner layouts in CAD. So before I start this, any initial questions before we launch into the process of doing the layouts in CAD? Okay, well, we'll go ahead and get started.
Bill, before we go there, you said that there was one pair of mullions that it was used for 3 different angles. And correct. That is because it was the closest thing that we have at hand to cope with the required angle?
That's correct.
Okay.
Today we're going to take a look at some of the layouts that we're doing on West Edge. We have an articulated type wall where there's a lot of inside and outside corners with various degrees. The mullion pairs are built to the closest degree that we had available if the floor plan angle didn't match an exact existing mullion pair. In some cases, we do have mullion pairs that are matching the floor plan angle, but a lot we're doing some slight layouts too. With that in mind, when we get to the corner conditions, we're using the mullion pairs as parallel to each other. So in this example, this mullion pair is designed for 66 degrees, but the floor plans that are being used are 66.17 and 67.13. The mullion pairs themselves are going to be aligned parallel, and then the layouts, we're going to build them as if we're going to place them on the floor plan. The first example that I have, this is a completed layout for an angle that we've built for these two mullion pairs, where the parts are built to 122 degrees, which makes a 61-degree miter. When the mullion pairs are parallel to each other, then the miters at the horizontals and the face stops are bisecting angles. The way that I've got this laid out is I've placed in all of the parts that run in and intersect with the vertical mullion, and I've put these on different layers so that I can turn the layers on and off if necessary. And I've color coded them so that I can create polylines for each of the parts so I can track the sizes when I do the layout. So for example, the yellow sill track is tracking to here. This has an offset of 1/16 off the center line, and that creates a 1/8 gap between the mitered sill tracks. That's what our decision was when we looked at how the parts and pieces went together, so the field could install the tracks and do a proper seal in between them. The face stops in this condition are offset 1/32 off the center line, creating a 1/16 gap between the two. Again, for a similar reason, so that when the units are installed, there's some installation and thermal tolerance. We also have a deep head filler part. When they did the performance mock-up, it was determined that those needed to be undersized by 1/32 total so that the parts would be able to snap in. So I have a 1/64 offset from the line of the vertical. Since I have this layout already completed, I'm going to use this as a base to create the layout for the next part that I'm going to work on. So my next part is going to be this W75, 52, 86, and 87, which is the 66-degree mullion pair. And then I'll take a look at our tracker to see which degree we're going to build this floor based on the floor plan. So I'm going to start by copying out these parts and placing them on my other page. So I'll do a Control-C, select this right at the intersecting of my dim points, and then select all of the parts in this detail. I'll go back to my existing layout. And for now, I'm just going to place these over here out of the way. When I go to my layout here, this is going to be a 67.2 degree that I'm creating this for the floor plan. So now when I save this drawing, I'm going to do a save as. This is in my sketch folder. I'm going to name it based on the detail 5.59, and OC is for outside corner. And then I'll put the degree in 67.2. Now I've got this file ready to be able to convert it from this degree angle to this degree. So I'll go through the process of how I'm doing that. I'm going to remove the existing vertical mullions that are in there and the existing glass. I'll just delete those out of that drawing. Then I'm going to lay out what my new degree is for this angle. I'll start by creating a vertical line so that I have perpendicular lines to create the layout with. So I'll just do the line command, starting at the very intersecting point, making sure my ortho is on, I'll make a 30-inch line. Now I have a line I can use to rotate. Since this is 90 degrees and I'm going for a 67.2, I'm going to rotate this line by 22.8 degrees. So I'll do the RO for the rotate command, select the object, which is this line, select the base point, which is right at that intersection. And I'm going to go minus 22.8. That'll give me my new degree. I'm going to check that by using the angular dimension here. And that's my 67.2 degree. I'll go back and make sure 67.2 is the degree that I'm going to build based on what the floor plan is. So I have my total angle now, which is a little different than how these mullion pairs are built. And that's why I'm going to continue this layout and align where all these parts are going to go. So in order to put this vertical mullion pair based on how the floor plan is going to work, I want to bisect this angle so that I can place this mullion pair along my bisecting angle. To do that, I'm going to create an X line. So I'll do XL, and I want to use the command B for bisect. And then I'll select the vertex, which is this very point at that intersection. And then the starting angle point. So that's going to be the first of my lines. And then the other line, which is the original base. So now I have my bisecting angle. I can then take my original center line of my vertical line, and I'll just move that over there and there. Now my bisecting angle is designated by what will be my vertical center line. I can double check that to make sure that it's bisecting this angle. So I have a 67.2. I'm expecting this to be 33.6 on each side. I'll repeat that, make sure that it's the same. And I have my 33.6 degrees. So now I've verified that my angle matches the floor plan and that this is my bisecting angle. For now, I'll get these out of the way. In order to put these parts in this layout, I'm going to use the align command, select the parts that I want, which is the vertical mullions, the face cover, the glass, and just the two pieces of gasket here in the front. And I'll align that based on this center point. So I use the align command. Select my parts, which is my two verticals, my vertical face stop, glass and gasket on both sides. And I'll bring the part numbers with me as well. The first point of my alignment is going to be the intersection of my dim points, and my destination point is going to be my original intersection. The second source point is going to be the center line of the vertical, and the second destination point will be the center of this vertical. Then I'll hit enter, I will not scale it, and then that brings my parts aligned. So now I have the verticals aligned where I want them. My next step is I want to rotate these parts around to be the same floor plan layout so that I can visualize the horizontals on both sides. In order to do that, I'll also use the align command. I'm going to select all of these parts. Start with my first source right at the corner. That's also my first destination point. Then the second source is going to be this outside point, and the destination will be my new angular dimension. So that rotates all of the parts around how I want them. The next thing I want to do is my alignment process doesn't necessarily put the vertical mullion aligned with the horizontal. So I want to make sure that that's going to align. I'm also going to need some layout lines in order to create the cut sizes for my various parts. So I'm going to drop the layout lines in first. From the center line, I want to do an offset of 1/32 to get the cut size for the face stop, 1/16 to get the cut size for the sill track, and then from the daylight side, I need a daylight in order to get the horizontal glass pockets aligned, and then I want an offset by 1/64 in order to get the head stop cut to size. So I'm going to start by doing an offset of 1/32, and I'm going to offset my center line once, and then one more time will actually give me that 1/16 dimension. So I want to create a little visual control here. So I'm going to match the properties. My first line is offset that 1/32. So that's my first dimension that I'm using. I'm going to use this blue line. So now I have a good visual control. Then the second line, the one that I'm using for the sill track, I've got that in yellow. So I'll use this yellow line to match my second one. Now I want to copy the center line so that I can align to the edge of this vertical. So I'll just do a copy and paste that in. I'll do an offset of 1/64. And then this one I want to match the properties and turn it white, the same color as my head stop. I've got all my lines set up now, and this line is my glass pocket line. So my vertical mullions are not fully aligned with the glass pocket. So I want to move those before I continue on the layouts. So I'll use the move command. And I'm going to select the vertical mullions. All the same parts that I used the align command to bring them into this position. I'm going to now move those. The base point is going to be the existing corner of the mullion, and then I'm going to place them aligned with the glass pocket. Now when I go to check this other side, this is my glass pocket line on this side. This will be lined up exactly with the corner of the glass pocket on this side as well. Now my verticals are placed where I want them to be, and I'll start doing the adjustments of my polylines in order to get my cut sizes aligned. I'm going to start in the same sequence that my color-coded lines are in order to keep easy track of my progress. So my first one, I'm going to move my dimension to my new location. Then I'll take my polyline of my face stop, move the front end of that polyline there. Pause for just a second there. After doing a lot of these layouts, I discovered that if I select the dimension line and the polyline at the same time, I can actually move both of those at the same time to my new destination point. So little process improvement occurred even after I made this session. There, and then the second one, I'll move over, and since I have that blue layout line, I can just easily snap to that. So that first one's done. I'll move on to the yellow line, which represents my sill track, and I'll do the same thing. I'll move my dimension over, to my new location. And then I'll actually adjust the polyline in the same manner. Keep working my way down. The next one, this is a horizontal body. This is going to be aligned with the side of the vertical mullion. So that intersection will come down to here. So this first one, I'll move to this intersection. Then I'll move my polyline. The next one will be the other horizontal part, which is at a slight offset than the first one. And I'll move the polyline itself. Get this in the right spot over here. There it is. Okay, next one's going to be that head stop. Adjust my size. And then I'll adjust my polyline. And my final polyline is going to be the drive-on stop on the back. This one is also offset 1/32 from the center line. So I'll move my dimension over to the intersection of my blue line here. Then my polyline, I'll move in the same way as I did the others. Bring that back to here. And here. So now my layout is complete. As I track through these polylines, I should have the face stop will be offset 1/32. The sill track will be offset 1/16. The horizontal members will be aligned with the vertical daylight. The head member will be 1/32 short of the vertical daylight. And the drive-on stop will be 1/32 short of the center line. Now I'll clean up these intersecting lines so that they're just connecting at these points. I'll remove the extra layout lines. I'll change the miter to what I'm building for this angle. And then I'll do a save on that into our sketch folder. And now we can use this layout as we're continuing to do the layouts for the rest of these walls. Thanks for watching. Okay, so that was the end of that lesson. What we're seeing on this is the Excel chart, for example, that we did the layout of all the different mullion pairs and then what the different floor plan angles were. And in some cases, we're using the same mullion pair. Like here, we've got this 6205 and 6206 that's used for an 87 degree and an 86 degree. So we had several of these that we had to build those little variables in order to accommodate the floor plan. And then that way, when we are doing our layout and our checking process, we can actually just use these dimensions in order to check all of our math. Now, one of the things that we came across yesterday as we were checking units is that we have embeds at the sill and at the head. So we wanted to make sure that when we did the cutout for the head member, it actually fit on the embed at the head. So we did some additional work and found the embeds on they're actually included in the set in the 4 series. And we laid out where the embeds were going to be to make sure that the cutout that we had placed in our prototypes would actually work. Now, for this particular project, we will need to do a pretty detailed study of this for each condition because the head embeds do not always align exactly with the sill embeds. They're not in the same forward to backward plane even in some cases. So we need to be very cautious with that. So some of the advantages for me of using that existing layout was I had the structure in place and I developed the process so that all of the different degrees went through the same series of steps each time so that I didn't have to rebuild all of these from scratch. So that's the base of how I was doing the layouts. At this time, we could just open this up for questions or discussion.
So I love the color coding concept. I used to do mine pretty similar. In more recent years, I haven't had to do very many of these because Joe does them a lot during setup. And then even Quentin was doing some on Santana West. And so these are really, really helpful layouts when it comes time for checking. Used to be one of the slow points in checking a quarter unit was having to do all the layout. So if these are done ahead of time and saved, then this can just be a checking tool. And but just one side note, back when I used to do these layouts, I did mine color coded as well. But I would, if I had a job with multiple corners, I would create a block that was a center line that was, let's say, white. And then I would just have my series of offset lines. And that whole thing was a block. And then I could rotate that to whatever degree I want. And then I didn't use polylines for all of my horizontals. But that way, all of my offsets were already done every single time. I could just rotate to the proper angle, explode it, and then just start trimming lines together. But I really like the method, and I use it a lot. Every time I check a corner unit, I look for one of these layouts, and it's really great. So.
And that's what I do. What you just described, that's what I do also. You know, I have the setup or like almost like a block of the horizontal lines. What is the outermost point of a part and the innermost point, and then that's where over that is where I place my my angles. When I have the angles that are contained in the corner that you're working on. And the use of colors is very useful, guys.
One of the ways that we're considering exploring this as we get into the segmented wall process is this is the floor plan that has the layout of what the different geometries need to be. And so the first few that I did, I actually placed them right on the floor plan. And in addition to having the reference sizes from one end, I placed the other ones in there. So I've got the reference on this end as well. And then I went back and just did the math for both sides based on the DP to DP, and actually put the finished part sizes and the glass size right on the floor plan. So this is a concept that we had toyed around with a little bit when we started Stevens Creek, but we never came up with the actual process to work its way through all of those stages. I haven't done this part for the remainder of the floor plans. I did over 40 layouts, so I haven't got back to these. We're working on another process now, but this is a potential where if we had this floor plan layout, you would still check the fabs like normal because you need to verify what the fab looks like, etc. But we could use this in order to determine like all of the cut lengths for all of your parts, for example. So that one document generated that one time would create that material flow so that all the way from setup through final fabs, you could verify your sizes just by looking at this one floor plan. So that's a concept we're experimenting with at this point. All right, any other discussions? That's it. Okay, well, thanks for attending the session. That video is available. I'll post this one, which will be pretty redundant if you watch this one and you'd already seen the other one, but that's okay. I'll get this one published as well, and then we can have the recording of how we go about doing this process.
Thank you, Bill.
All right, thanks
Thank you,
everybody.
Bill.
Bill.
Thanks, Bill.
Thanks, Bill.
Thanks, Bill.
Thanks, Bill.